good to have you once again.
Thank you, ma'am.
Today, in our computer electronics class, we shall be looking at logic gate. We shall be looking at what class?
Logic gate.
Thank you. In our previous class, we dealt with binary numbers. Do you still remember that?
Yes, ma'am.
Binary numbers are what?
0 and 1.
Okay, thank you.
Alright, binary numbers take us to our class for today, which is on logic gates. And of course, what are binary numbers? They are numbers that allow you to represent large data with zeros and ones. So what is logic gate? In defining logic gates, certain characteristics must be looked into. Of course, they are electronic circuits, but you have some set characteristics that must be adhered to, which are what? They are electronic switches, that it's either on or off. They operate only in binary, and of course they make use of 0 and 1. And having said this, we have 7 logic gates. What are they? We have the AND gate, we have the OR NOT, NAND, NOR, XOR, XNOR gate. Of course, all these gates are 7 in number, but the first 3 are regarded as the basic gates. Why are they basic gates? They are the fundamental gates that are recognized. Other gates are recognized, but they are formed from these other gates. Are we together? So, as we proceed, we'll see it. Let's pick on the AND gate to see what the AND gate is. So, AND gate, or it is a gate that allows you to have your output as high, that is as 1, if your inputs are all 1. That is, it's a gate that allows you to have your output to be high if all the inputs are high, where we have A and B as the input and Y as the output. Having said this, let's check on what a OR gate is, which is the next gate. A OR gate is a gate whose output will be 1, that is to be high if any, in this case, either A or B, if any of the inputs is actually 1, if any of the inputs is actually high. Are we together? Fine. But what's the minimum input? The minimum input is 2, but definitely not 1. Definitely not just A, but we could have A and B to be our Y. And of course, it has a representation. How is it represented? For 2 inputs, we have A plus B. For 3 inputs, we have 3A. So, having said this about the OR gate, I will move further to check the third gate, which is our NOT gate. A NOT gate is a gate whose output is always the inverse of the input. That is, if the input is 1, the output is going to be 0. So with this, we will bring our class to an end, and let's have a little revision of what we learned today.
Learned about the 3 basic gates today. Who can tell us what an AND gate is? Yes, class. Oh, yes, let's have you.
My name is Akirele God's Gift. An AND gate is a gate whose output is high if all the inputs are high.
Please clap for him. Okay, so we have OR gate. Who can tell us what the OR gate is? Oh, yes, please.
My name is Uzama Emanuela, and OR gate is a gate whose output is high if any of the inputs is high.
Thank you. Please clap for her. So far, so good. It's been an interesting class. Do we have any question? Oh, yes, please.
My name is Olale Kondamilola. My question is, what's the difference between the primary gate and the secondary gate?
The primary gate and the secondary gate. Of course, like I explained to you, that the secondary gate is actually formed from the primary gate. The secondary gate is what? So the basic gates, the main gates that we have are the AND gate, OR gate, and the NOT gate. The secondary gates are formed. They are what?
Formed.
From where?
Primary.
Thank you very much. Any other questions? Oh, in absence of that, it's been a wonderful time. It's good to have you in my class, and we hope hope to continue from here in our next class. Until then, it's bye from us at Government Technical College at Adidingbe. Bye.
Alright, we'll continue from where we stopped in our previous class. Shall be looking at truth table right now, and of course, what is truth table? We'll be looking at the relationship between the gates. What the uniqueness of the gates, representing them in tabular form, and looking at the uniqueness and the different attributes we actually I mean the different attributes of the gates. We are going to be looking at them and representing them and see their relevance, how they're different from each other. So let's go on the ride. I'm sure you enjoy it. Okay, all right. Welcome back. We'll be looking at what truth table is. Truth table, was that what I said? Yes, truth table. Okay, what is truth about the table? We'll get to understand. Of course, it's a table, and let's see how truthful it is. So, definition of truth table: it is a table that shows the operation. What operation? Operation of a particular gate. What gate? Maybe AND gates, OR gates, either of the gates, any of the gates in a graphical form, and of course, that is representing the gates in their form, representing it in another form, that is in graphical form, that is in a tabular form. That's just all it means. And of course, truth table has another name. It is also regarded as AND gate. Sorry, did I say AND gate? No. Action table. It's also known as action table. Truth table is also known as action table. Please do always remember that. Peradventure you stumbled on the word truth table, it's telling you the action table. That is telling you the action taking place in that table. So what does it mean? How does it mean to to form a truth table? Let's see. For you to have a truth table, there is a standard formula, that is 2 raised to the power of n, where n is the number of input variable. Are we together? For you to come up, for you to have your number of, for you to form your truth table, there is a standard formula, and the standard formula is just 2 raised to the power of n, where n is the number of input variable. Your n could be a, it could be a and b, it could be a, b, c. Are we together? So that's just all it takes for you to formulate your table for each of the gates. So in having known this, let's pick on the AND gate and see how we can apply it. Remember 2 raised to the power of n, and let's just move to a AND gate to understand better. Okay, so we have the AND gate. The AND gate says, of course, for truth table of the AND gate, we have 2 input variables here. If you look vividly, what are the input variables that we can see here? We have a and b equals y. So our a and b are the input variables. Are we together? I remember the golden rule says 2 raised to the power of n, where we put our n to be 2, that is a and b. So 2 raised to the power of 2 is what? 4. So the table is going to be in 4. We're going to have 4 zeros. 4 line rule. So we have our a and b, which is 0, 0, 1, 1. So let's look at it. It says the first one, the rule says all inputs must be 1. It is an AND gate is a gate that accepts the output to be 1 if the inputs are both 1. Are we together? That is, y will be 1 if and only if a and b is 1. Here we have a to be 0, b to be 0, and y definitely will be 0. Here we have a to be 0, here to be 1. Definitely is knocked out already. Except for the last one where we have it to be 1 and 1. That means it's going to be 1. That's the rule for AND gates. Are we together? We'll understand better. Let's look at the 3 input variables. For 3 input variables, let's see what we are going to have. For 3 input variables, we're going to have it to be A, B, C. and you start your numbering from there, 0 1 0 1 0 1. Then you move to the next one, 0 0 1 1. The next one, I'm sure you'll be wondering why it's not 3 zeros. No, it's not going to be 3 zeros. It's just going to be 4 zeros, because logic gate has to do with twos. It has to do with two binaries. Are we together? So we have it to be 0 0 0 0 1 1 in that thread. So let's look at it and understand better. In this case, AND gate says it's a gate that the output will be I, that is 1, if and only if all the inputs are I. In this case, all the inputs are low, so definitely here it's going to be low. In the next one, says where all inputs are I. The same thing here, we have it to be low low I, so definitely it's going to be low. Already where we have 0 0, they are knocked out. Let's look at where we have 1, it's high, it's low, so it's knocked out already. Yeah, same thing. Here is 1, here is low, here is I. Of course, remember you can use your word interchangeably. I 1, where I is 1, where high it's 1, high it's same thing as low. Okay, so here we have here to be low, here we have 1 1. Oh no, this is knocked out also. So let's look at the last one. I think it's just the last one that it's going to make it through. And what does the last one say? It says it's I. Okay, and definitely our outcome is going to be what? I. Are we together? One thing you should always remember is how this table is formed. Remember, just forget about the Y in this case first. Come up with your A, B, and C before getting our Y. Let's look at 4 input variable to understand better once again. For 4 input variable, what are we going to have? Oh, sorry, the labeling are off. The first one here is A, B, C, D. Then the last one is the Y. So let's leave it. Of course, the same rules apply. But remember that the labeling is always 0 1 0 1 for the first one. Under our D, under the C we have 0 0 1 1 0 0 1 1. Under B we have 4 0 0 0 0 0 1 1 1 1. 4 of it onto the trend, same trend. Then the last one, I'm sure you will wonder why not 6 0. I've told you it's always in power of 2. Okay, 2 raised to the power of 1, 2 raised to the power of 0 is 1, 2 raised to the power of 1 is 2, 2 raised to the power of on and on, like that. So here the same thing happens here. Here where we have zeros, they are all knocked out. Where we have 1, look at it, we still have 0 here, we still have 0 here. So except the last one, I think it's for AND gates, I think it's just the last one that gets to satisfy, where we have 1 1 1 and gives us to be 1. Are we together? Look at it once again. So it's just the last one that satisfies 0. So having understood this, let's move on to the other gate, which is OR gates. So let's have our OR gates, please. Yes, OR gates. Yes, this is the truth table for OR gates. Remember the rules. It says provided if any of the inputs, where is our input A and B, if any of it is I, then our output is I. If any, in this case we have 0 0. Is any I? No, so it's not to be 0. So in this case, if any, we have the first one to be 0, we have the next one to be I. So what does it say? It's going to be I. Here we have 1 and here we have 0, and it's going to be 1. Do you understand? Here in this case, both are I, so of course it's going to be high. So that satisfies the rule also. Do you understand? Please take a good look at it once again to pick it up. Just have a look, have a look, have a look. In this case, once again, like I said, the rule says where any. So we have where any, where it's I, here it's I, and in this case, both are high. Do you understand? Do we have any question with this? Okay, let's proceed. Let's take to the 3 input variables for OR gates. So let's move on to 3 input variables for OR gates. Then we understand more what our OR gate table is saying. 3 input, please. So for 3 inputs, We have A, B, C. Remember the labeling. It's always 0, 1, 0, 1 for the first one. 0, 0, 1, 1. The third one is going to be 4, 0. It's in 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power. That's how it's formed. So look at it very well. Do we understand? Any problem? Just the last one. So let's move on. So for having land and OR gates, let's try for let's try for 4 input variable. Yes, let's give it a try for the whole 4 input variable. Yes, what do we have? We're going to have A, B, C, D this time around, where A will start our labeling from D 0, 1, 0, 1. The next one 0, 0, 1, 1. The next one 0, 0, 0, 0, 1, 1, 1, 1. And the last one we'll go on to have it to be 0, 0, 0 in 8 places, then 1, 1, 1 in 8 places. Are we together? Then of course we'll move to the rules, which says for hand gates, you know what it says are provided all the inputs are I, then output will be I. That's when you will be able to have your one. Why the other one for all gates? If any of the inputs is I, then it's going to be I. So of course we are going to have a lot of I for the OR gate. So is that taken? So now let's continue with our class. Okay, let's take on to the NOT gate, a unique gate. NOT gate. The NOT gate is telling us that if it is not this, it's the opposite. NOT gate. Another name for NOT gate is inverse gate. That is opposite. Opposite. That's what it means. If you look at this y equals a in this place, there is a bar on it telling us it is not it. In this case, it's always having 2 inputs. For NOT gates, NOT gate can only have 2 inputs. That's 0 and 1, since it's just one variable input. So, and of course, I told you it's an opposite gate. It's one variable input. You cannot have A and B for NOT gate. Sorry. You can only have A. You only have A. So here we have 0. Of course, what does that tell you? I told you another name for NOT gate is known as inverse gate. It's known as what? Inverse gate. So opposite of 0, you have it to be opposite of 0 to be what? 1. And in this case, where you have 1, opposite of 1 is what? 0. And if it is not A, it is bar A. This A, where we have y equals A, is having a bar. I don't know why it's not coming up. That could be my mistake. Sorry. So it's having a bar on it. Are we together? So if it is not A, it is bar A. So let's pick onto other gates, as this is quite simple to to explain. The NAND gate. What does NAND gate say? It's just the opposite of AND gate. Remember what AND gate says? If any of it is what if all are I, that is when you're going to have it I. So in this case, if all are low, you're going to have it I. And in this case, where it's just the opposite, they answer the other way around. It's just the other way round. Now, are we together? It's the opposite of the AND gate. Remember, just close this, do your AND gate, and transverse back to AND gate. In AND gate, where all are high, where you have this, 0 and 0, you're going to have you're going to have the output to be what? To be 0 for AND gate. So for instead of you having 0, you change it to 1. For AND gate, it says if all, yeah, of course for AND gate it's 0, so you change it back to 1. That's the rule. Where we have for AND gates here to be I and I, instead of it to be I for AND gate, I told you it's the opposite of AND gate. Just change it back to 0, which is the OR gate. Is that taken? And same thing on and on. Maybe let's actually take the 3 input variable for NAND gate to understand better. 3 input, please. Yes, 3 input variable where we have ABC. Of course, here we were told that for AND gates, please kindly remember that I think I like using AND gate rather than coming up with the definition of NAND. Says if all are high, in this case all are low. Okay, for AND gates it's going to be 0. But because we are dealing with NAND and NAND gates, it's going to be 1. Are we together? So let's quickly let's just breeze down here. If all are high for AND gates, remember AND gate, if all are high, then it's going to be high. So of course we are dealing with NAND gates. Instead of we having here to be 1, we'll take it, we'll inverse it to, we take it to the opposite, which is instead of it to be 1, it's going to be 0. So what you need to do is just do your AND gates and change it back and do the opposite of it. That's all. So let's move on to the next gate. What other gate do we have here? We have the NOR gate. Let's look for 2 inputs. NOR gate. What does the NOR gate say? Same thing. It's also the inverse of the OR gate, which is if any of the inputs is high. In this case, if any of the inputs is high, here is telling us that it's opposite. Just do the opposite of it too. Are we together? Here and here is 0 and 0. Definitely it's going to be 0 for all gates. So take it back to the take it back to the inverse of it. Here for all gates it's going to be 0 0 0 0 1 1 1. So now just take it back to the opposite. Are we together? Just remember the coding rule. If there's any confusion, you can always go back. That's the beauty of this package we're using. You can always go back to visit your to visit each of what we've said to reverse back. Are we together? Thank you. So let's move on from here, since we understand that what we need to do is get our OR gate and take it and do the opposite of it. So let's check for 3 inputs, please. 3 inputs. Okay, for 3 inputs, we have ABC. Says if any, remember, if all inputs are low, output will be high. That's just what this is telling us. If all inputs, that's just it. Okay, that's another language we could use. If all inputs is what are low, output will be high. If all inputs are low, do we have all our inputs to be low here? Yes, all are low. That's why we have here to be 1. In this case, we have all to be, no, we don't have all to be low. So do you understand? If all inputs, so it's only number 1 that satisfies the rule, the first one. If all input, if you look at it, it's more like you just take a study look at it and tell us the uniqueness at the end of your study. Okay, are we together? So let's move on to the other slide, which is the XOR gate, exclusive OR. Exclusive OR. Look at our exclusive OR gate. What is our exclusive OR telling us? It says if the number of ones is odd at input, output will be high. What does that mean? That is, if you remember your even and odd number. Odd numbers are 1, 3, 5. Okay, so if we have the number of ones at input to be odd, then it's going to be high. Let's see, do we have it to be odd? No, we have 0 and 0 and they are even, so it's going to be 0. Here we have 0. We have, how many ones do we have here? Just 1, so we have it to be 1. How many ones do we have here? 1, so it's 1. We have 2 ones here, so does not satisfy the rule. It says odd numbers. Are we together? Does not satisfy the rule. Let's look at it quickly once again. In the first one we have 0 and 0. It's going to be 0 because it's not odd. How many ones do we have in the next slide? The next line here, next column, next row rather. We have 0, we have 1, so we have just 1 here. So it's going to give us 1 because it's actually odd in this case. Well, fine, you might not be able to understand it more in this context of 2 variables. Let's actually look at 3 variables where the table is a bit expanded, and so we can count the number of odds and the number of ones there. So let's use the 3 input variables, please. For three input variables, what do we have? We have here to be 0, 0, 0. In this case, it's not, it's going to be 0. Then the next one is 0, 0, 1. How many ones do we have here? 1. So it's actually odd. So we're going to have it to be 1. Do you understand that? Yes, good. Let's move to the next one. 0, 1, 0, 1. How many ones do we have here? We have just one. So it's going to be 1. Are we together? So we'll move on to the next one like that. How many ones do we have here? Same thing, except here we have, how many ones do we have here? We have 2, 1, 1. So it's even. So we can't have it here. So we're going to have 0. Are we together? How many ones? 1, 1. It's going to be 0. Except here we have 1, 2, 3, and that's odd. So we're going to have 1. Is that taken? Do we have any question? Fine. So let's look at the last one, but it's not actually the least. The X nugget. Excuse me, please. X nugget says it's a rule. It's a get that of course, the output will be high if and only if the number of inputs is even. This has to do with even X or and X no. They are just the even and odd thing. So in this case, telling us except if it is even. The first one is 0 and 0. If the number of ones, not just even numbers, if the number of ones. Here we have even 0, but it's not acceptable because it's not 1. Here we have 0 and 1. It's just 1 1, so it's odd. Here we have 1 and 0. It's one variable that is just 1 1, so it's odd. So we still have it to be odd here. Here we have 1 and 1, 1 and 1, 1 to 1. Remember that? Oh, funny way. 1 and 1, so we have it to be what? 1. Are we together? Yes, we're together. Let's look at it once again. It's telling us that it is only when it is even. So it's just the last row that meets with the rule, and that is 1 1. Are we together? So I think we'll understand when the case of even and odd, why using like 3 input or 4 input variable. So let's use a 3 input variable so we can see more of even and odd in the table. Thank you. So in this table, how many odd do we have in the first slide? The first one is 0 0 0. So it's definitely 0. We are dealing with 1. 0 0 1. How many is just 1? And it was odd. Just 1 is odd. So it's going to be 0. It does not satisfy our row. Are we together? Yes, thank you. So the next one is what? 0 1 0 1. It's also odd. So let's move to the next one. 0 1 1. Yes, this is even. 2 ones. So we're going to have 1 to be the output. Are we together? So let's look at the other one. So 1 0 0. So it's odd. We have it 1 0 1. It's even. So we have 1 to be there. And we have 1 1 0 and 1. So what does it tell us? It's what? Even. So we have it in the 1. In this last row here, we have it all 1. So it's odd. So it's out of it. Yes, thank you very much. I think this explains it, and I will expect you while you do the 4 input variable for the XOR and XOR gate. So so have a good look at it. Yes, thank you.